Good everyone, my name is Graphics. In this tutorial, we want to solve a problem involving friction and we'll be considering wedges. So this is wedges in friction. Is that okay now? And the question goes like this. It says, in the figure above, two wedges A and B are in contact such that the line of action of wedge B is perfectly horizontal. The wedges are used to lift a load of 2,000 kg. The coefficient of friction on all rubbing or contacting surfaces is 0.3. Gravity G is given as 10 meter per second square and the angle of inclination is 30 degrees. Study the given figure properly and determine the value of the effort P required to lift the load. Now, first of all, we need to understand what a wedge is. We say a wedge is a simple tool or a device that we use to lift heavy load or we use to adjust the position of a body. With the diagram you are seeing here, it will tell you that B is planning or B will be used to lift A because the force here is being applied horizontally. As you are pushing this is going up. And with the help of what? The guide. These two things you see here are the guide. The guide is just to direct where A will pass through, right? To avoid wobbling. With this guide, A is only restricted to follow vertical direction. So the guide restricts the wedge A to move only vertical. Is that okay now? Now this is the horizontal flow here that helps to what? Slide wedge B along horizontally when you apply force P and the angle is given to be what? 30 degrees. Now the first thing I'll first of all do here is to write out what? The givens, the data givens. So the first thing here, we are told that we are given what is called the coefficient of friction, right? And we are given the mass. So we say that, let me write it this way. The data given, so the data given here, you can see that the first one is the mass in kilogram. The mass is given to be 2,000 kilogram. So since the mass is given, automatically weight is given. What is the weight? Weight is what? Mass times what? Times gravity, right? Now the gravity G is given to be what? 10 meter per second square. So my weight here will now be given to be W will now be given the 2,000 multiplied by 10, and that's going to give us what? 20,000, right? Newton. So this is what we have here. So my weight is what? 20,000 Newton. Now the next thing is given to be the coefficient of friction, mu, is given to be what? 0.3. Are we good? 0.3. And the angle given, theta, is given to be what? 30 degrees. This is what is given. But remember, we are told that all contacting surface have a coefficient of friction to be what? 0.3. Now the question is, how many contacting surfaces do we have? Now, one of the contacting surfaces we have is the surface of the guide. So this is, I will call this to be one of the contacting surface. I'll call it 1. Now, another contacting surface between wedge A and B, this will be what? The second contacting surface. And the third contacting surface is in between B and the ground, right? So this is the ground here, the floor or the horizontal ground. So we have this third contacting surface, 3. How good now? So we have 3 contacting surface. Is that okay? Now what I'm going to do after doing what I'm doing here is this. I need to draw out what is called the free body diagram. So we should draw out what is called what? The free body diagram. Now you see this wedge A and B. Let me show you a good illustration of what this simply means. Let's take this horizontal ground here. Let me call it the floor. Floor, right? Let me call this my T square to be the floor. Are we good? And let me call this my set square to be the wedge B. Are we good? Let me call the set square to be what? The wedge B. That is moving in this manner, right? And let me call the other set square here to be wedge what? Wedge A. Now what do you notice? When I guide this, if this is moving in this manner, what do you notice? It means that this will be going what? Upward, right? As I'm applying the force here, this one will be going what? Will be going upward. That is the aim, to move this upward. So what I'll do is, I want to separate both of them. This is my wedge A, my wedge B, and I want to split them into 2 to see what we are going to be having. So when I do that, this is what we are going to have here. So the FBD, the free body diagram, right? This is what we are going to be having. Now, this is my wedge B, right? I mean, this is my wedge A, and this is what? My wedge B. So I splitted them. Don't forget, the contact surfaces are 1, 2, and what? And 3. Now we need to draw all the forces acting on this wedge A and B. Now we have this at this point here, which is given to be what? I'll call it to be my weight now, no longer 2000. It's acting downward this way. So I'll call it 20,000 Newton at this point. 20,000 Newton, right? And I have a force P at this side here. I'm going to call it the force P, right? This is my force P acting horizontal. Now I want you to understand, according to the third law of motion, it says to every action there is an equal and opposite reaction, right? Now look at this. At the guide here is in contact with wedge A, right? Because of the fact that the guide is in contact with wedge A, there will be a reaction because the contact is the action, right? What is the action? It is moving along the guide horizontal and what? Vertically, upward and downward. So there's a contact. It is rubbing the surface of this guide, right? Now, because of that, there will be a reaction acting at that point. So I'm going to use this to represent it. I'll just put it there and I'll call it R1. Why am I using R1? Because that is point 1. You can decide to use R3 depending on what you want to use. You can even decide to use an alphabet A or B depending on how you understand it. So this is R1, right? Now I said something. As I push this force here, what happened? This move upward or downward. If I push it forward, it goes upward, right? As it's going upward, what happened? Friction will occur. And what is friction? Friction is a force that opposes what? Relative motion. So that means since it is going upward, right? Since it is moving what? Upward this way. Since it is moving upward, right? What will happen? Friction will be coming downward. The frictional force will be what? Will be opposing the motion due to the surface in contact. So I'm going to put it here. my friction force will be coming downward here. So I'll call it this way. This will be, I'll call it F frictional force 1. You can see that because it is moving upward. I showed you earlier using my set square here. I said when you apply a force this way, right, as this is moving in this manner, this way, this is going upward. You can see if I try to push my force here, what happened? This is going upward. As it's going upward, friction will be affecting it, making it opposing the motion, which will be coming downward. That is why this arrow here is coming downward. Now, similarly, there is a reaction force. Any surface in contact, right? That means there's an action there. So where there's an action, there should be a reaction. And the reaction is always acting perpendicular to the surface. This is acting perpendicular. That is why it is what? 90 degrees. So I'll do the same thing here. It will be acting perpendicular to this surface here. So I'll put it this point here. So this is what we have here to this surface. You can see that, and that will be another reaction. I'll call it, because it's point 2, I'm going to call it the arrow 2 here this way. You can see that. Similarly, as I push this force, what do you notice? Let's do that again. As I push this force this way, what happened? This is going backward. This is the wedge B. It's going backward. As it's going backward, it's also moving upward. So there's a force. So the motion of this is backward. So the motion of this backward, automatically friction will be opposing it. So it will be coming in the other way around like this. So I'll be having this way. So it will be coming in this manner. Right? So I'm going to be calling that my reaction force. So it will be what? F2. Frictional force 2. You see what I show you now? So this will be going backward. That will be the frictional force 2. Similarly, there's a surface here also, still point 2 at wedge B. This is for wedge A. Now we're going to wedge B. There's a surface there too. If I should come at that point, there will be a reaction force at the surface in contact, and that will be at an angle of what? 90 degrees. So if I do that, friction, so there's a reaction force due to the action of the rubbing surface. So I will have this way, right? Perpendicular to that point. So I'll still call it what? I'll call it arrow 2. Right? Because anything at this point is what? Is 2. Now what do you notice? What is moving forward? This is what is actually moving forward here. As I'm pushing this way, this is going forward. This my wedge B is going forward, because look at the force P. So I'm pushing it forward this way, right? The friction will be opposing it. So if the wedge B is going forward, friction will be opposing, will go in the other direction. So we're having it this way. It will be coming in this direction. So it will be going opposing the direction of what? Of friction. And that will give me what? My F2 again. You can see that? That will be what? FF2 again. Now, similarly, this is another surface in contact again. That is the wedge B is in contact with the ground floor here, right? So there will be a frictional force acting, a reaction, right? Wherever there's an action, rubbing is the action, there will be a reaction that is acting perpendicular to that what? Surface. So I'm having it this way. This is my reaction here. I'll call it what? Arrow 3. Now, if I'm applying this force forward this way, friction will be opposing relative motion, will go in the opposite direction. So this is how it will be going opposite direction in this manner. So I'll call it what? My F3. Frictional force what? 3. Is that okay now? So this is what we have. This is the free body diagram of that we have. This is for wedge B, and this for what? Wedge A. Are we together now? Now, if you notice now that in the world of force, we only have horizontal and vertical component, just like we have a male and a female, and we have good and bad, we have up and down, right? In force, we only have horizontal and what? Vertical component. Now, FF1 here is vertical, it is safe. R1 here is horizontal, it is safe. 2000 Newton is vertical, it is safe. Now, but what do you notice? My FF2, frictional force 2, is inclined, and my R2 is also inclined. Now, what am I going to do? I need to resolve this force. I need to make them either they should be vertical and horizontal, right? So they are what? They are inclined. Whenever you see an inclined force in mechanics or in any part of physics, you have to resolve it into what? Vertical and horizontal component, right? So if you don't really know how to resolve forces, resolution of force, you can even click on this link here. It will show you on how to resolve forces, right? But for the benefit of those watching this video, I'll be showing you on how to what? To resolve each of these components one step at a time, right? Now look at what I will do here. If you look at this, let's consider R2, right? We're considering force what? R2 here because it is inclined. It is not vertical, neither is it what? Is it horizontal? So let's consider it. So if I consider it at the point where it meets this contact surface here, I'm going to draw a vertical line downward this way. I'll draw a vertical line downward this way. Just watch. A vertical line downward this way. And an horizontal force downward this way. You can see that? Now, the angle, what is it forming? It's forming a what? A triangle. So let me bring that out fully so we'll have a better understanding. So if I come there, I'm going to be doing it here. So we'll consider this triangle here. Can you see that's from a triangle? Showing that this point here is given to be what? 90 degree, right? So if I should draw out that triangle, let's draw it out and see what will happen. I have this triangle this way from here. I have this triangle this way. You can see that. Then I have the vertical one, this line here, this way. You can see that. And I have this way. Just combine here from here to here. You can see that. Right? Now this point here is my R2. Here is the arrow. I mean this arrow here. This is the 90 degree. Then the angle will be in between here, and that is angle what? 30 degree. Right? Now because of the angle is in line with this 90 degree here will be my what? My f of x. That means we call it f of x. Then here will be what? F of y. Is that okay now? So if I should apply my sine and my SOHCAHTOA, that is applying sine of the angle. So let's get f of x and f of y. So if I should use sine of theta from the word so, it means opposite over what? Hypotenuse, right? So where the angle is facing is my opposite, right? That is Fy, all over hypotenuse is the longest side, that is the force itself, which is R2 is my hypotenuse, and that is what? R2. So now we're having theta is 30, so I will say that my Fy, I want to cross multiply, this will come here to be R2 sine what? Sine 30. How good now? So we have R2 sine 30. So if I should press R2 sine 30, so if I have R2 sine 30, then the next one will not be what? We'll not consider for cos. So we have for what? For cos theta. So for cos 30 or cos theta, it will give me what? Adjacent over hypotenuse. That is what? What is my adjacent? My adjacent is my what? If this is my opposite, this will be my adjacent. It will be my f of x, fx, all over what? Hypotenuse, arrow 2. So my fx here, the fx we have, if I cross multiply, this will come here and we're having arrow 2 cos 30 degree. Is that okay now? So this is what I am going to input here. Let me show you. So this is what I am going to what? Input here. So what you notice, the arrow will be facing in this direction. This will come here, right? And the other one is going to come here. So if I want to do, either I place it here, there's something you need to understand, right? I can actually make this to be like this also. See what I want to show you. I can actually make this to be like this. Let's show you something. You can see that. So it's the same thing. F of x here, from here to here is f of x, from here to here is also what? F of x. From here to here, f of y, from here also is what? F of y. So if I want to, I can still place my force to be at this point here. Is that okay now? So I can come here, the arrow, since it's going outward, it will go this way. You can see that? And I can just put it here just to avoid confusion. So let me just put it here. So it's coming here this way. How good? So from here now, look at what will happen. This side here is my f of x, just like what we have here. I mean f of y, you can see it's going this way, and my f of y here is given to be what? Arrow 2 sine 30. So we have my arrow 2 sine 30. Alright, y f of x, whatever is there is here. So I use this component here, which is here, and that will be what? My f of x will be what? F of x will be equal to what? Arrow 2 cos 30. So this is my vertical and horizontal component. Is that okay now? Now similarly, I would love to consider frictional force 2. This one here. So let's do that and see. I will just draw the force this way. Look at the force showing you that at this point here, if I should move this in this way, I'll use my faint line. You can see that? And I'm having the vertical line here too. What do you notice? It is forming a triangle. So let me bring out that triangle here and let's see how it goes. So at this point, I'll have something like this. You can see that? And also, I'm going to have something like this. Then I'll close here up this way. So that is the triangle I am considering. So the angle will always be at the edge here. This is theta. So meaning here is also what? Here is 30 degree, right? And here will be my what? My 90 degree where they are meeting. So because of the fact that this is 30 and this is 90, here will be my f of x. Y here will be what? My f of y. This point here, seeing which is the arrow acting in this direction, will be the frictional force 2. You can see that? So we still apply the same rule here that says that my sine theta, the sine theta or sine 30 is equals to what? Opposite over what? Hypotenuse. So the side the angle is facing is my opposite, Fy. All over hypotenuse is the force itself. That is what? Frictional force 2. Now if I cross multiply, the Fy here will be giving me frictional force 2 sine what? Sine 30. Is that okay? Similarly, if I consider for car, that is cos. So if I go for cos theta, which will be giving me cos 30, right? It will be equals to what? Adjacent over what? Hypotenuse. So if where the angle is facing is my opposite, automatically the other side is what? My adjacent. So this will be my what? Fx all over what? Frictional force 2. So if I cross multiply, my Fx here will now give me frictional force 2 cos what? Cos 30. So we've gotten the Fx, I've gotten the Fy. So this is what I'm going to replicate here. So at this point here, this force, at this point here, I'll just come and draw it here. This force is coming in this manner. Let me a little bit extend this here a little bit later. So I'll just come here. This force here is coming in this manner, it's coming down. Right? And the other one here too is going in this manner here too. So from this point, since the arrow is going this way, the arrow will be going outward since the arrow is going outward. So let's see. Now this is Fy coming down, and this is another Fy here, right? So what's my Fy? Fy is ff2 sine 30. So here will be what? I'll put it this way. My Fy is equals to what? Frictional force 2, right? Sine 30. You can see that. Why this here will give me frictional force 2, that is my Fx, will give me frictional force 2 cos what? Cos 30. You can see that. So this is what we have there. So we have successfully resolved this force here. Now we'll do the same thing here also. All together now, we are going to do the same thing here. So I like to move forward. So I will consider this at this point too. Since this is inclined, right? Let me consider the arrow 2 first. So if I do that, I'll be having something like this. Where it meets here, I'll take it up this way. I'll take it up. Then I'll close it up too. What do you notice? It is forming a triangle. So let me draw the triangle at this point here. So I'll be having something like this. Let's do it at this point here. So I'll be having something like this. Let's do it here. So I'll have something like this. I see that. Then I have a vertical line coming down this way, and I have an inclined line connecting to this point this way, and this is where the arrow is. So that arrow is my arrow 2, this arrow 2 here. Then this is the angle 30, right? This angle between these forces is 30. Now this is where they meet perpendicular. So because of the fact that here and here is, this is 90, this is 30, this will be my Fx. Y here will be what? Fy. So we'll do the same thing. You consider, use your SOHCAHTOA. So if you use a SOHCAHTOA, this will give me the cos. Let me start with sine. So we have sine theta or sine 30 is equals to what? Opposite over hypotenuse. So where the angle is facing is my opposite. So that's Fy, right? All over hypotenuse, which is the force itself, the longest side of triangle, arrow 2. So my Fy will now give me arrow 2 sine what? Sine 30. So that is my Fy, right? Similarly, my cos 30 will now give me adjacent over hypotenuse. So if this is the opposite, automatically is my adjacent. So it will be Fx all over what? Arrow 2. All together. So my Fx here now, will now give me arrow 2 cos 30. That is what I am going to input here. So I'll just draw the line at this point. So let me just extend here a little bit. Let me extend here a little bit so it will move forward here. Alright, so if I do that, so I'm going to have this coming this way, just like what I did here, and I'll have this coming down too, just like what I did here. So the arrow will now be for this, and this will be for this. So let's see. Now I told you earlier, you don't have to get confused. I can complete it this way. See what I'm showing you? If I draw my line this way, and I also draw it this way, right? If from here to here is fx, automatically from here to what fx. If from here to is fy, automatically from here will what fy. Nothing changes. All together now. So what I'm going to do here is that this angle you're seeing here, this line you're seeing, is this here, and that is fy. So what is fy? Fy is what? R2 sine 30. So you'll give me my R2 sine what? Sine 30. Right? Y for fx will give you R2 cos 30. So I'll write it this way. R2 cos 30. So I've resolved that. Now the next thing we're resolving will be this. Right? So this will give you a better insight. I can easily just extend this a little bit here. See what will happen? So if I just use my red biro just to show the difference between both of them, where it meets here, I'll just draw an inclined line this way, faint line. I'll come here also, I'll do the same thing this way too, faint line here, right? What do you notice? It is also forming a triangle, right? It is forming what? A triangle. So it means that the angle between here and here is 90. So let me replicate that triangle again, so we'll see how it goes. So I have a triangle this way, and I have the vertical one this way, and it's connected to this, right? So at this point, this is where the arrow is. This arrow you're seeing is moving in this direction, and that will be the R2. No, that will be the FF2, frictional force 2, right? And since this is the angle here, 30, here is what? Perpendicular, that is 90. So this will be my f of x, and here will be what? My f of y. All together. So we apply the same thing that says that what? My sine theta, or let me call it sine 30, right, is equals to what? Opposite over hypotenuse. So where the angle is facing is opposite. That is fy all over hypotenuse, which is the force itself. The hypotenuse of this, that will be ff2, right? So my fy will now give me ff2 sine what? Sine 30. I cross multiply this to multiply this. So my fy here is this, right? So this is this guy we have here, which is this guy you're seeing here. This line you're seeing here is this line you're seeing here. This point here is this point here, right? So, and this guy is going upward. So I'll take this guy upward this way in my triangle. You can see that. So I'll put my arrow facing that direction. Are we good? So similarly, I'll do the same thing here too. That will be my fy. So what's the value of my fy? My fy is given me to be ff2 sine 30, right? So we're going to do that. So the forces of this is what? ff2 sine 30. Let me just write it out. ff2 sine 30. That is this guy here. And the other one, I told you this can also be here this way too. fs/fx. So if I do this way, here will also be what? My fx. All good? So here will be my fx. So let me just do that. So this is my fx, and that will be what? ff2 cos 30. You can see that? fs is what? So if I do it, I'll be having the cos 30 is equals to what? Adjacent. If there is opposite, this will be my adjacent, fx all over what? ff2. So we now say that the ff2 will now give me, the it will now be equals to the fx will now give me ff2 cos what? Cos 30. So that's why I wrote ff2 cos 30 here. So we cannot resolve this. The fact is that this is horizontal and this is vertical. This is horizontal, so we can't resolve them because they're already horizontal and vertical. We only resolve inclined forces. Is that okay now? So this is what we have here. Now we will now start. The first thing we'll do, I take my book here. I am going to, so if you have actually found this helpful, please just click on the subscribe button, like the video, and also comment. Now let's move on. Now from here, I want to start resolving the force. So I'm going to write that consider from here. All right, consider wedge A, right? So we want to consider wedge A. This is our wedge A that we have here. Is that taken now? So if I want to just draw it out, I'll be having something like this. Now this is what we have here. So I've brought out this guy out. I want to consider just wedge A, right? So what I'm simply going to do here is this. I'm going to say that we apply the condition for equilibrium, which is summation of f of y and f of x. So the first one, I'll write out this way, that the summation of f of x is equals to what? 0. And we want to consider, we will consider, right, any force acting forward to be what? Positive, and any force acting backward should be what? Negative, right? So that's what we'll do. So summation of f of x means horizontal component, any force that is lying down, right? Now if you look at this arrow 1, it is horizontal, it is lying down, right? So and it's facing forward, I will say any force facing forward is positive, so we'll be having arrow 1, right? Now the next thing again, look at this force, is also lying down but it's facing backward, and we'll say any backward force is negative, so we have minus what? Frictional force 2, right, cos 30. Is that taken? Now look at this, also is lying down, horizontal component, facing left, so it will be minus r2 sine 30. Is that taken? So that's all what we have. So equals to what? Equals to what? 0. So I don't really need all this or all this because I've already resolved. I only need vertical and horizontal. Is that taken now? Now I will write it this way. Recall, we know that frictional force FF will give us coefficient of friction multiplied by what? Multiplied by R, the reaction, right? So since we are dealing with frictional force 2 here, this will give me what? R2, and what? We have mu2. So R2, since the mu is the same thing for all quantities of it according to the equation, so I'll just mu or mu2 is the same thing. So this is what I have here. So I'm going to implement this into this equation here. So if I do that, I'm going to be having R1, right, minus, instead of me putting FF2, I'll put what? The mu R2, right? So cos 30 minus R2 sine 30 equals to what? 0. Now if you look, what is common on both sides? R2 is common to both sides. So if I bring R2 out, I'll be having the R1 here will now be equals to R1 minus, right? We have R2 open bracket, we'll be having mu cos 30 minus sine 30. I close up the bracket, equals to what? 0. Now if you're wondering what I just did, I factorized, because when I bring R2, because it's common to both sides, because R2 times this will give us this, and R2 times this will give us what? This. Now let's now move forward. Let's implement. So from the question here, we're told that the mu is 0.3, So I will say that R1 minus R2 into bracket 0.3 cos 30, right, minus sine 30, close the bracket, equals to what? 0. So if I implement this, we'll now have R1 minus R2, right, into bracket. Now 0.3 cos 30 will be, we have 0.2598 minus sine 30 will be, sine 30 is giving us 0.5, right, equals to what? 0. So from here we'll now say that R1 will now be minus R2 into bracket. If you subtract 0.2598 minus 0.5, that will give us minus 0.2402. So we're having minus 0.2402. This is what we're having here, right, equals to what? 0. So if I should this to come out, so if I move this to this side, right, so I'm going to be having R1, right, minus times minus is what? Is plus. We have what? R2, or better still, 0.2402 is equals to what? 0.2 R2 is equals to what? 0. I multiply both of them, so R1 will simply be equals to what? Minus 0.2402 R2. So I'll term this equation what? Equation 1, right? So we've done for summation of f of x. The next thing we'll do will be for summation of what? F of y. So for summation of f of y equals to what? 0, we will consider upward force to be positive and downward force to be what? Negative, right? So from that we move forward. From this, what we have here, we have upward force. This is a downward force. 20,000 is facing down, so it's negative. So minus 20,000, right? Now FF1 is facing down, right? So it will be minus F1, frictional force 1, right? The next thing is, this is also facing downward. We have minus F2 sine 30, right? This is now facing upward, plus R2 cos 30 equals to what? 0. So we only consider the vertical component. Facing down 20,000, facing down FF1, facing down FF2 sine 30, then facing up. So because facing down is negative. So from here, I'll put it this way. Recall, we know FF, frictional force, is equals to what? Coefficient of friction times what? R. So when we talk about frictional force 1, to be coefficient of friction times what? R1. And when we talk about frictional force 2, because of what? Coefficient of friction times what? R2. So we implement this in the equation above, and we're going to be having minus 20,000, right, minus, instead of writing FF1, I'll put what? Mu R1 minus, so I'm writing FF2, I'll put what? Mu R2, then I have sine 30 there, sine 30 plus R2 cos 30 equals to what? 0. Now in doing that, we move forward from here, but we know our mu is given to be what? 0.3. So I'll be having minus 20,000 minus 0.3 R1 minus 0.3 R2 sine 30, right, plus R2 cos 30 equals to 0. So if you implement that, we have R2 here, and we also have what? R1 here, right? So what I'll just do is I'll be having minus 20,000, right, is minus 0.3 R1 minus 0.3 sine 30 will be, well, 0.3 sine 30 will be 0.15. So we have 0.15, right? R2, I multiply these two, so it gives me 0.15 plus what? If you multiply cos 30 is what? We have cos 30, that is giving us 0.866. So we'll now be having 0.866 R2 equals to what? 0, right? Now, but R1 is equals to what? Minus 0.2402 R2. You can see that from here, from equation 1. So I'll now see that minus 20,000 minus 0.3 into bracket minus, I'll now put R1, 0.2402 R2. I'll close the bracket, start taking, so I've implemented here. So minus 0.15 R2, right, plus 0.866 R2 equals to 0. So from here, I will now have minus 20,000 minus 10 minus is what? Plus. So 0.3 times, well, 0.3 times 0.2402, right? So that will give me 0.0726. We have 0.07206 because minus and minus is what? Plus. So minus, we have R2 there, still there, R2, so minus 0.15 R2 plus 0.866 R2 equals to what? 0. So bring all the R2 together, we're having minus 20,000 plus, so let's add the remaining one together. So we have 0. Let's see. So this will now give us 0.78806, 0.78806 R2. That's when you add this 0.07206 minus 0.15 plus 0.866. So to give us this, they are like terms, equals to what? Equals to 0. So we now see that the 0.78806 R2 will now give what? I take minus 20,000 to this side to give us just 20,000, right? So if you make R2, it's right the formula, R2 will now give me 20,000 divided by what? 0.78806. And our R2 will now give me, if you divide 20,000 divided by what? 0.78806, so that will give us 25,378.78 Newton. So that is the reaction of R2, right? Now we're done for that R2. Now we'll move forward
I'll go for what? We've gotten for R2 to be this, that is 20,000 times 0.78806, right? So the next thing we'll now do is we'll now consider wedge B. So let's consider wedge B and see what will happen. So this is what we have here. I have redraw wedge B. So this is my wedge B here. So we'll apply the same thing. We'll now write the summation of all the horizontal components is equals to what? 0. So we want to consider any force going forward to be positive, any force going backward to be what? Negative. Right? So let's see. For f of x, any force lying down, arrow 2 is lying down, that is facing forward and is positive. So we're going to be having arrow 2 sine 30. Right? This is also lying down, that is plus, is facing forward. That will be frictional force 2 cos 30. Right? This is also lying down, that is frictional force 3, so it will be positive, plus frictional force 3, right? So I'm not putting cos or anything, I already explained to you. And this is facing back, that's the force, minus what? P equals to what? 0. Now we know that, recall that frictional force is equals to what? Coefficient of friction times normal reaction, or the normal force. So when it is frictional force 2, to be the normal reaction 2, right? So from here, I will implement it here. And similarly, if I have the frictional force 3 to be coefficient of friction multiplied by the normal reaction 3. So I will now implement this in my equation above. So this will now give me R2 sine 30 plus ff2, instead of that I'll write what? Mu R2 cos 30 plus ff3 is what? Mu R3 minus what? Minus P is equals to 0. Now if you look at this very well, we already have the value of what? Of R2, right? The value of R2 is what we gathered here from this point here, and that is what? 25378. So I'll implement it here and I say that, but R2 is equals to what? 25378.78 Newton. So I'll put it here. So I'll have 25378.78 multiplied by sine 30, right, plus mu is 0.3 as given in the equation here. Then we have R2, still the same thing, multiplied by, we have 25378.78. That again, 378.78, close the bracket, we have sine what? We have cos 30, right? Plus, similarly, the same thing happened here, mu is 0.3, right? R3 we don't know. So R3 will be given here, we'll calculate for R3. Now from here, we'll calculate for the R3. So we have R3 here, right? So equals minus P is equals to what? Is equals to what? 0. Is that okay now? So from here, we'll move forward. Now from this point here, we'll now say that we'll start multiplying. 25378.78 times sine 30 will be 12689. We'll have 12689.39 plus 0.3 times 25378.78 cos 30. We have 6593. We have 6593.600, right? 004 plus 0.3 R3 is equals to what? I'll take P to this side, is equals to what? P. So when I add these three together, is what I'll be having here. So I'll add this plus this plus this plus this, both of them will give us, that will be 19282.99 plus 0.3 R3 is equal to what? P, right? So I'll call it equation what? Equation 2. How good? So from here we have, so similarly we'll do for what? For summation of f of y equals to what? 0. So we'll consider any force going upward to be positive and any force coming downward to be what? Negative. So let's see. From here, this force is going upward, so it will be ff2 sine 30. So we have F frictional force 2 sine what? Sine 30, right? Now the next one again, this is coming downward, that is minus R2 cos 30 minus R2 cos 30, negative because it's facing down. Now this is going up, so we have minus, that will be plus R3. So equals to what? 0. Now we know very well that recall frictional force is equals to what? Coefficient of friction times the normal reaction. So when it is frictional force 2, to be coefficient of friction 2, and times normal reaction 2, right? So I'll implement it here. So we're having mu R2 sine 30 minus R2 cos 30 plus R3 is equals to what? 0. Now if I implement it, mu, we know it is what? 0.2. So I'll have 0.2 multiplied by, what is R2? R2 that I calculated for here is given to be what? 25378. So we have 25378.78 times what? Sine 30 minus R2 again here will give me 25378.78 cos 30 plus what? Plus R3 will be equals to what? 0. Now if you do the needful here, you multiply 0.2 times 25378.78 sine 30, then minus, so if we do that, you'll be having, so that will give us 3806.817 minus, if I multiply all this, 25378.78 cos 30, I will have 21978. We have 21978.668, right? Plus R3 will now give us what? 0. So when you collect like terms, so I'm going to be having this minus 3806.817, right? So I'm having minus
18171.8512 plus R3 equals to what? 0. So from here, we'll now say that the R3 will now be equals to, this is coming to the other side, become positive 18171.8512, right? So from here, this is my R3. Don't forget, we're working in Newton, right? So from here, we're getting the R3. Now, I will now substitute R3 equals to 18171.8512 into equation what? Equation 2. And this is my equation 2 here. So from here, I will now be having 19282.99 plus 0.3. What is R3? That is 18171.8512, right? Then we have what? Equals to what? Equals to P. So from here, P now will now be equals to, if you multiply this by 0.3, then you multiply by 0.3, you'll be having 19282.99 plus 5451.5553. So P now will now be equals to, so plus 19282, right, 0.99, 19282.99. So we have our force to be 24,734.545 Newton. So that is the force that is required, which is also given, which is the same thing as P is also the same thing as saying 24, right? 24.73 kilonewton to any of them, right? So in kilonewton, that's our value. So if we're also told to look for R1, for instance, some cases they might tell you to look for the reaction. Now you realize from this equation here, from wedge A, we have R1 to be this, and we have gotten the value of R2. If I take my R2 and put it in my R1, right, I'll be having the value for what? For R1. Is that okay now? So this is what we've done. We successfully calculated the force that is needed to push this wedge B in order to lift this wedge A. So we need 24,734.545 Newton of force required to lift the weight of what? 20,000. Is that okay now? So if you have found this video helpful, please don't forget to like, subscribe, share the video. Thanks for watching.